Alright, we're about to prove a few things about parallelograms. I'm not going to slow down much because there's a lot to get through, but our first proof is going to show that opposite sides are congruent. So we're going to use this space to show opposite sides are congruent, and then we're going to come into other proofs that show different attributes of a parallelogram. So here we go. Alright, prove the opposite sides of a parallelogram are congruent. Alright, so given A, B, C, D is a parallelogram. They tell us that. Prove that AB, I'm just going to mark it as congruent to CD. Maybe I shouldn't mark it yet, because we'll probably be marking this up while we do it. We want to prove the opposite sides are congruent. So this says ABCD is a parallelogram. Well, I see that written right here. So I'm going to write the word given. Alright. Draw DB. So I need to come in here, and I'm allowed to draw when we want to. Through any 2 points, there can be a given line. Alright. And we know that AB is parallel to DC. I'm just drawing that in here. And AD is parallel to BC. Alright, well, I've got a lot to do right now. Alright, so that is the depth of a parallelogram. That's actually what a parallelogram is. Alright, so let's see what it says. ADB is congruent to CBD, so ABD right here is congruent to this. Those angles are the same. That was ADB. Oh, I went the wrong way. And this one right here is congruent to this one right here. So what we're doing is, since we got these parallel lines with a diagonal written across here, right, we can see that we have alternate interior angles that are congruent. Alternate interior angle conjecture. And then it says DB is congruent to itself. Let's mark that. That is the reflexive property. Something is congruent to itself. Alright. So if you look up here, I can now prove the top triangle is congruent to the bottom triangle because we have angle, side, angle. Asa! Remember, everything but butts and batteries works. So let's go ahead and say it. We're going to say triangle ABD is congruent to triangle. Well, it matches up with ABD. That would be CDB. Alright. And once you prove two triangles congruent, as long as the sides match up, you can say the sides are congruent. So let's see. AB and CD, they're the first two in both cases. Right? CD and CB. Alright, so CD's here. Oh, AD and CB. AD's here and here. CB's there in the same spot. So, do you remember that? It's CPCTC. So, by breaking it into triangles that are congruent, we can prove the opposite sides are congruent in that parallelogram by corresponding parts congruent triangles. How can you use rotational symmetry? Well, if you notice, if I turn this 180 degrees, right, the two sides would be the same again, right? So the top has, if a 180 degree turn does it, top has to match bottom, left has to match right. 180 degrees has top equal bottom and left equal right. Okay, that's it. That's one pair. We're going to cheat these quick because there's a good amount of them. All right, so there's one proof. I'm going to save this. We're going to hit another proof on the next page.